Hello, welcome back to Dnaofbioscience. So this is the continuation of the last class. That is the equilibrium theory of island biogeography. So if you have not seen the theory of island biogeography, please refer the previous video. You get an idea about the theory. So in this lecture, we are going to discuss about few questions regarding the theory of island biogeography. So before starting the theory, let me again summarize what is theory of island biogeography. Okay, so according to that theory, the number of species inhabiting an island is on the dynamic equilibrium between the immigration of new species and the extinction of species which is previously established. Okay, so you can say it is the number of species in an island. It reflects the balance between the rate of colonization with the rate of extinction. Okay, and the island will reach equilibrium when the extinction rate equals to the immigration rate. Okay, so let's start with the question one. So according to the theory of island biogeography, which of the following should have the highest number of species? Okay, so the first one is the small and far island. Second one is large and far island. Third option is small and near island. And fourth option is large and near island. Okay, so we have already discussed that the species which is inhabiting in a smaller island, they have more prone to extinction. Okay, so obviously as there is extinction process occur, the number of species are less. And in case of far island, there will be less number of species. Okay. The next is about the large and far island. Yeah, obviously in the large island there will be more number of resources. So the number of species are also more. This one is right, but the second one, that is far island, this one is wrong. So we need to exclude this option. The third option is small and near island. So as I already told, in the small island there will be more extinction, and near island. So what will happen if the island is closer to the mainland? So generally, the closer islands have more species on them than the far island. How? Because the closer islands are easier to reach. Okay, and the extinction is lower on island close to the mainland, right? Because of the livelihood of immigration. So that's why in case of near island, the number of species are more. So we got answer, that is near island, and in the fourth option it is given large and near island. So this is the correct option for this question. Which of the following should have the highest number of species? Okay, so the answer is large and near island. So large, as there are more number of resources, so there is more number of species colonization, and in the near island, as it is closer to the mainland, it is easier to reach, and extinction is also low because of the livelihood of immigration. So let's switch to the next question. The next question is about, it is a part C question. Okay, so they have given one diagram, one graph. So the question is, the above graph illustrates two lines that represent the immigration and the extinction rate of an island based on its distance from mainland and its size. So I have already mentioned in the last lecture that the richness is completely based on the one is the distance from the mainland, this one, okay, and second one is the size of the island. So one is distance from the mainland and about the size, whether it is small or large size. Okay, so the question is, which of the following is true for this island? Okay, so let's see the options. First is, it is close to the mainland and is very small. Okay, so as you can see here, this is for the number of species, this is the immigration rate, and this is for the extinction rate. Okay, so as you can see in this picture, the extinction rate is not so large, right? So it is close to the mainland, it is very Small. No, it is not smaller island. In case of smaller island, we have already discussed the extinction rate is more, right? So we can neglect this option. The second is it is far from mainland and it is very large. Yeah, the second option is right, that the island is large as the extinction rate you can see. This is not very large. Okay, this is not reached to the maximum. This is less than maximum and the extinction rate is less in the larger islands. So this option is true and it is far from the mainland. Okay, no, this is not far from the mainland. This island is very close to the mainland. How? Because here you can see the immigration rate is increasing. Right? Immigration rate is increasing means there is more number of species. Right? So more number of species are present in the near island or the island which is close to the mainland. Okay. So this option is also wrong. The third option is it is close to the mainland and it is very large. So this is the right option. And the fourth option, it is far from the mainland, it is very small. No, it could not be small as the extinction rate is less. When the extinction rate is more, then only you can say that it is the smaller island. Okay. So in the smaller island, the extinction rate is more, and in the larger island, the extinction rate is less as compared to the smaller islands. Okay. So in this case, the answer is 3. That is, it is close to the mainland and it is very large. Next, let's switch to the third question. So the third question is following feature shows Mcarthur and Wilson's equilibrium model of biota on a single island. So here they have given the theory name in the form of the person who discovered them. So they have given the Mcarthur and the Wilson equilibrium. So you need to remember that also, but who discovered the equilibrium theory of island biogeography? So it is Mcarthur and Wilson who discovered this theory. So you may get question like this: the Mcarthur and Wilson's equilibrium model of biota on a single island. This is a question from June 2011. So let's see the question. So one graph is given and the question is in this figure terms A, B, C, D in the order. So we need to select the correct option for A, B, C and D. Okay. So let's see first the option 1. So A is extinction, B is immigration, C is the equilibrium number of species and D is the size of species pool. C is no doubt, C is the equilibrium number of species. It is very clear from this graph. And D is also the number of species. This one is also correct. Okay. But the A and B options are wrong. Let's see the second statement. So in the second statement, it is given the A is the immigration rate and B is the extinction rate. So, and C and D are the C is the equilibrium number of species and D is the size of species pool. So this one is the correct option. Let's see the third option. The A is extinction, no. And the fourth option, immigration, that is right. B is extinction, right. But C is not the size of species pool. C is the equilibrium number of species and D is the number of species that is present. Okay. So you can see the rate of the immigration to an island are mainly determined by the distance from the mainland to the island, and the rate of extinction on the island are mainly determined by the island size. Okay, so B is the extinction rate and A is the immigration rate. Okay, so to understand this graph, you need to recall the theory. That the theory explains that there will be balance between the number of immigration to the number of extinction. Then only the equilibrium will reach, right? The island will reach the equilibrium where? When the extinction rate equals to the immigration rate. Okay. The next is, so this is also, this part is also for the colonization, okay, colonization of the new species. If this previously occupied species is already vanished or it is zero, then only the new species will form, right? And if the previously occupied species are present, then the colonization of new species will be less, right? So the A option is also for the immigration or for the colonization of the species. Next question is, which of the following is not true? Okay, so you need to find the wrong statement. Okay, CSR always gives this type of question that which of the statement is not true. Okay, so first option is the number of island species increases, a large fraction of new immigrants will be members of the species already present. As I already mentioned that as the number of island species increases, okay, a larger fraction of new immigrants will be members of the species already present. So as the island species increase, if there is the previously occupied species is less or it is becoming zero, then only new immigrants will be the member of the species already present. And so this is the right option. The second is the colonization rates are greater on near island than on the far island. So this one also I have already discussed in the colonization or the formation of the new species, colonization of the new species, the rates are greater on the near islands than on the far islands. Because the reason is, in case of near islands, the species can able to reach, right? As it is near to the island, the species can able to reach it. Okay. And the second point is, as the extinction is very low in the near island, so the immigration rate is more. Okay, so you need to remember 2 points. First is, in the smaller island, it is easy to reach. Okay, and the second point is extinction. So the last point is extinction rate decreases as the number of species increases. No, this is the wrong statement. The correct option is extinction rate generally increases as the number of species increases. Okay, so the example is in case of smaller islands, as the island is very small, there will be the competition between the intra-species and the inter-species, right? So for that, there will, for the limited resources, there will be competition and then the extinction of the species takes place, right? So here the number of species are increasing, but due to lack of resources and due to because of intra and interspecific competition, the extinction rate also increases. So the extinction rate increases as the number of species increases. Okay. Then let's switch to the last question. Not last question, last one. So the question is the question of June 2016. The question is, which of the following is not a prediction arising out of Wilson-Mcarthur theory of island biogeography? Okay, so the first option is the number of species on an island should increase with its size and area. This is the correct statement, as the number of species on an island should increase its size and area. Right. The second is the number of species should decrease with increasing distance of the island from the source pool. This is also a correct statement. That is, the number of species should decrease with increasing the distance. Right, I have already told. The species which are near to the main island, they have the more number of species because the colonization or immigration part is more and the extinction part is less. Right? So, the number of species should decrease with increasing distance of the island from the source pool. That is, here in the statement 2, it is describing about the far island. Okay, not near island, far island. Then the fourth point is the species richness on an island should be related to its average distance to the neighboring island. This is also a true statement. The The third statement is the total number of species should be common and frequent. So this one is the wrong statement. The total number of species, whether it is immigration, extinction or the colonization, it should not be common or frequent. It's nothing like that. The frequency is always there for the total number of species, right? And it is not very common. Right, if there is a small island, then there in that region only the extinction will occur. Right, in the large island the extinction will be less. In the near island the colonization will be more. In the far island there will be less number of species. So it is not that much frequent and it is not very common. Right. So total number means the changes, right? The immigration, the colonization, or the extinction part. Right? So that is the total number of the species. So the answer here will be the total number of species will be common or frequent. This is the wrong statement. Next question is at equilibrium, which of the following is not true? The first one is a continual total number of species occurs when to recurrent colonization and extinction. This is a true statement as there will be always some colonization and extinction, right? And in that manner only the equilibrium maintained and the rate of colonization is equal to the rate of extinction, right? So there is a continual total number of species occurs owing to recurrent colonization and extinction. Right? Second is the total number of species remains approximately same. Now this is also the correct statement. Third statement is the species composition in an island is constant. So this statement is wrong. The correct statement is there is a constant turnover species. That means if there is some rate of immigration happens, then there will be equal amount of extinction will happen. So then only the equilibrium will reach. So there is a constant turnover of species, not the species composition. Okay. So here the answer is option 3. The species composition on an island is constant. That is wrong statement. The statement is actually there is the constant turnover of species. Okay. So extinction is the disappearance of species from the community, and immigration is the formation of new species or the colonization of new species. So this relationship between the species extinction and the species colonization, that is the species turnover, and that states that the equilibrium value of an island is proportional to the number of the immigrants that come to the island and the loss of the individual due to the immigration or the extinction. You may get part B and part C questions. So if you like this video, hit the like button, share with your friends, and do not forget to subscribe this channel. Thank you.